In this tutorial, we learn to visualize the relationship between a categorical variable and a continuous variable. So we'll generate a plot, something like what you're seeing on the screen. So along the x-axis, there's a categorical variable called MPG category. It has got three values: low, medium, high. And along the y-axis, there's model year having continuous values 70, 72, and so on and so forth. And as you can see in this relationship that low MPG category cars were available till 76. The medium category car were always popular, so that's why you're seeing the values all along. And the high MPG category cars became popular, I guess, after 76 onwards. And after 76, there are no low MPG category cars. So we'll learn how to generate plots like this to visualize relationship between a categorical variable and a continuous variable. The data set that we will be using is called as Auto MPG dataset. This is freely available from UCA Machine Learning repository. And the dataset has got columns like MPG, cylinders, so on and so forth. So to start with, what we'll do is we'll create, so the first two lines of the code, we are just importing Pandas and Seaborn libraries. In the line number 10 of the code, we are loading the dataset MPG. And then we are printing the info of the dataset using the info function. As you can see here that there are 398 values in this dataset. And then we will create a new a variable called MPG category. This variable will be created out of the variable MPG, and what we will do is we will divide the MPG into different bins. So 0 to 15 will be called as low, 15 to 30 will be called as medium, and between 30 to infinite value, so anything more than 30 will be called as high. So we'll use the pandas cut function to do that. What my suggestion would be to go and read the API for pandas cut function or any functions that we are using here. So you could go to Google and say pandas data frame cut, and then that will show you the API for the cut function, and you can read more about these functions. Okay, so so when I run this code, you will see that okay, so I got an error saying unexpected labels value, so it should be LABELS, right? So it's just a typing error. So once I run this, then you will see that my data frame has got a new column called MPG called MPG category, which is towards the end, which is this one. And as you can see here, this MPG category column, which is this one. So if the value is 15, then it's low. If the value is like between 50 to 30, for example 18, it's medium. It's less than 15, then the value is low, and then we'll have some high value as well. So this is a high value. So if the MPG is 35, which is more than 30, the value is high. So we have converted a continuous variable into a categorical variable. Okay, so now we will write the code for generating a relationship plot between a categorical variable and a continuous variable. Before that, we could just quickly check the frequency count. So we could say df, and then the name of the column is MPG category. So we could say MPG category dot value count. So it will tell us that what's the frequency of these categories. So if I print the frequency, so if I just run this, so it will store it into a frequency series, and you can see that MPG category medium, there are 244 cars with medium category, there are 85 cars with high category, there are 16 cars with low category. All right, so now we will use the we will generate the plot. So the plot, the function that we will use is called Seaborn catplot function. All right, and in the catplot, first we need to provide it the data frame. So data is df, and then we will say along the x-axis we will use mpg category as the variable along the x-axis. Along the y-axis we want to plot a model year variable. So model underscore year. The kind of plot we want to generate is a scatter plot. If you want to know more about Seaborn cat plot, then you can go to the API. So Seaborn, this is a Seaborn cat plot API, and you can read more about this function. The one which we are using is this one, strip plot. So strip plot, you can get it by having the kind as strip, which is what we did. All right, so I'll generate this plot now. Okay, so once I generate the plot, I'll show you how the plot looks like. So this is the plot. And as you can see on the plot, it has plotted a category along the x-axis and a continuous variable along the y-axis. And then you can infer some relationship out of this plot. One quick thing, there is, if you look at the API, there is this variable called as jitter. So what jitter does is that I'll just show you. If I make jitter equals false, right? So I'll make jitter equals false and I'll draw the plot, and you can see how the plot looks like when jitter is false. So what jitter does is, because there could be more than one values, few values may be overlapping, maybe there more than one value for the 70. If you make jitter false, then it will put it exactly at the same point. So there will be overlap and you won't really know how many values are there. By default, what it does is it keeps jitter equals true and it adds a slight jitter. So the effect of this is that the values which are having the same value for the y-axis, they are separated slightly, so you can see range of values here. So that's what the impact of the jitter is. One other thing is, if so in this we have given x-axis as a categorical variable and y-axis as a continuous variable. We could also give we could also use a category plot. We could also give both the x and the y as continuous, in which case it will treat the x column as a categorical variable. So if you look at df, and if I say cylinders, for example, so if I use cylinders cylinders as a column along the x-axis. So although cylinder is not a categorical column, but it has got discrete values like 8, 4, 6 and all that. So it will treat it as a categorical variable and plot it accordingly. So if I make the jitter equals true here, because I do want to see the values separate, and then if I plot it, you will see the plot something like this. Okay, so on this plot you can see that although cylinder is not a categorical variable, but the SNS category plot function is treating it as a categorical variable. And so 3, 4, 5, 6, 8, so these are the possible values for the number of cylinders. And you can see that along the y-axis there is model year, which is a continuous variable, and you can infer different relationship out of this different information out of this plot. So one of the quick messages from this plot could be that the 4 cylinders have always been popular, because you can see values in 70, 76 all along. The number of 3 cylinders were popular in 72 and then a little bit in 75 and then 80, otherwise they were not popular otherwise. The number of 4 cylinders and 6 cylinders have always been popular. The number of 5 cylinders have not been popular at all. So there were a few cars with 5 cylinders in 70s and 80s, 78 and 80s, but otherwise, the number of 5 cylinders was never popular. So you can infer different messages from the plot. Okay, so that's the code. Thank you so much.